Next we look at the following question. How would we express the set of points which lie equidistant from the point 310 and the point 82? Okay, we want all the points that are as close to 310 as they are to 82. Of course, there's a point halfway between 310 and 82, and that's equidistant between 310 and 82. But there are a whole lot of other points that are also equidistant. There's a point down here that's the same distance here as it is here. If we let x, y stand for the coordinates of the point that's equidistant between the 2 points, then to say that x, y is the same distance from here as it is from here is to say that the distance from here to here is equal to the distance from here to here. Now, the distance from here to here is this, and the distance from here to here is this. So that xy is equidistant between the points if this distance obtained from the Pythagorean theorem and the fundamental triangle is equal to this distance obtained from the Pythagorean theorem and fundamental triangle. Okay? That is, these 2 points, wherever they are, the point looks like it's horizontally across from this one and vertically up from this one, but it could be out here someplace where there would be a triangle with 2 non-zero sides. And if we applied the analysis that we just went through to the fundamental triangle from here to here, we would get this. And applying the same thing to these 2 points, we get this. So these are our distances. Again, if the points are equidistant, these distances have to be equal. Okay, so here, if xy is equidistant from 310 to 82, this distance has to equal this distance. We write that down as an equation. This is the one distance, this is the other. Here's, let's see, this one is the distance here, and this one is the distance that we had up here. That's an equation. We want to solve or simplify that equation and see what it looks like. See what the expression for the equidistance of these points comes out to. So what we do is we square both sides of this equation, and we obtain, of course, this equation, which just removes the square roots. We can then expand these binomial squares in the obvious manner. X minus 3 squared is x squared minus 6x plus 9. We do the same with the y minus 10 squared and this square and this square. And what we get, and you should verify this as always, is this equation here. Now that looks pretty intimidating. It looks pretty fearsome because it's got all those squares and everything else. But a kind of a nice thing happens here. You got x squared here and you got x squared here on this side. What happens? You subtract x squared from both sides, you no longer have any x squareds in the equation. And the same thing happens to your y squared. So all your squared terms go away and you're left with just multiples of x and y and constant terms on both sides. We take this equation and we solve for y. Now I'm not going to go through the details of solving this equation for y by this point in the course. That should be something that you can do very easily. As a matter of fact, most people can do that pretty easily at the very beginning of the course. So you should just solve this, write down this equation and ask yourself, what do I do to solve for y? Solve it, and this is what you're going to get. Now, what's this? That's the equation of a straight line. Slope 5/8, y-intercept 41/16. Now what's the meaning of this line again? Well, this line is a set of points that are equidistant from 310 and 82. We can picture that. Zoom in a little bit. Okay, here's the point 310, here's the point 82. Here's the line on which xy lies, the line that's equidistant, and you can see that every point on this line is very plausibly the same distance from this point as this point. Pick a point here. This distance is the same as this distance. If I've sketched this accurately, then that's certainly going to be true. If it's not sketched accurately, then improve the sketch and see what we have. The slope of this line, this line is y equals 5/8 x plus 41/16. The slope is 5/8. The y-intercept, of course, is 41/16. What's the slope from 310 to 82? Well, you can draw your triangle, find the rise and the run, and you'll find that the slope is negative 8/5, which is the negative reciprocal of this slope. Now you know that the set of points equidistant between these 2 points lies on the perpendicular bisector of this segment. If you remember any of your high school algebra, you'll remember that.